So we want to show that for any real number x, that this equation holds true. Now we have two cases. X is a real number, so it can be either positive or zero, or it can be negative, right? There's no third option. Either positive, it's either greater than or equal to zero, or it's less than zero. So let's break this up into two main categories. Let's assume that x is greater than or equal to zero right there, which means that the absolute value of x equals just x itself because it's positive or zero at its lowest value. So here's what we have. This is true, right? If x is that right there, then that means that that is that, right? The absolute value of x would just be x itself. Now we have an equation that we can build upon. So here's what we get. So I've written down again with a little bit of space. Now I want to multiply both sides on the right-hand side by the same number. And I choose to multiply both sides of this equation by the number x. And since x is greater than or equal to zero, this equality holds true. And this is actually by property number 12. If you carefully look at property 12, this is permissible. Now I've kept everything the same. That stayed, the dot is there, multiplication. But instead of x, I'm going to change it into something else. Instead of x, how about I turn it into the absolute value of x by substitution? After all, these are equal. And so substitution allowed us to turn this into that. And now we're pretty much good because that just means that this is the absolute value of x squared. And of course, x times x is x squared. So that's exactly what we're trying to show. So the case where x is greater than or equal to zero has been established. Now let's finish by looking at the case where x is less than zero. And of course, under this case here, which is that guy, under that case, we have that this equals the bottom. So the absolute value of x equals the additive inverse of x. Now we can build upon this equation. Now here I choose to multiply again by a positive quantity. I am going to multiply by negative x because I know that x is negative itself, right? X is less than zero, x is negative. So that means that negative x is actually positive. And so really I've just applied property 12 all over again like we did the first case. And now let's see, let me keep that the same. Now here again, instead of negative x, let me replace it by the absolute value of x. That's just by substitution. But on this side, I want to use something a little different. If you look at property number 6, carefully look at property 6. Property 6 says that this here is the same as that there. And yeah, you really want to look at property 6 because that gives us that into that. So that is what we wanted, and so we're pretty much done.